Yeah, all you have to have is 3.
But you want 4.
So from here, you've got the intersection. You can see where it happens. Your calculator has a function, has the functionality of calculating that. Second trace. There's a little blue button up there that says calculate. One of the options on the screen now is the intersect, number 5. Bless you. Everybody see that? Intersect?
What's that?
Hit 5.
5. Oh.
Wait, what?
I see. 5.
Once again, let me back out. I'm at the graph. Second trace, number 5. And now it asks you a question. First curve. Hit enter.
I didn't do that.
You don't have an 84. Where's your 84?
Second.
Oh, that's right. We're still trying to find that, aren't we?
Yeah.
Yeah. And then you hit second curve. Oops. And then hit enter. The reason why it asks you those 2 curves is because obviously in your y equals functionality of the calculator, you can put in 7, 8 different equations. I just recommend just putting it in 2 at a time. That way it doesn't get too confusing. Guess. It's no longer raining. And hit enter.
Oh, say enter again.
How was
Yep.
that right?
Yeah. I have no idea. I have absolutely no idea what the point of saying of guess is. Potato.
You said it.
At least. No,
Okay.
that.
No, I really have absolutely no idea why they say guess. So, but there you go. There's the solution. The solution set. The answer to this system of equations is -1, 3. That's your answer.
Okay.
All right. So try these 2. These are 2 different problems.
Where's the guess button?
What's that?
Where's the guess button?
There is not a guess button. It's when you're hitting the when it's asking first curve, second curve, then it says guess. I don't know why it does that. I have no idea. Well, your calculator wasn't open when I went through the whole process, so why don't we first of all remember solve for y, and then go from there.
2 and 3.
No. If these 2 guys were the exact same line, all right. I don't know where it went. Say they're the exact same line. What's their answer?
The same.
How many points do they have in common?
All of them.
So,
All.
infinite, thank you. Infinite solutions.
That's what we read?
Yeah. If it winds up being the same line, it's an infinite number of solutions because they're line atomic with one another. They have all points in common. So in this case here, you get to draw the good old-fashioned hyperbolic paraboloid of Pringle. Did you guys, it's not a made-up story. This is not like Slope. This is a true story.
Be honest with us here.
I'm honest with you here. You know what Pringles are, right?
Yeah.
Pringles,
all the
potato
time.
chips.
That's a have my goodness consumed.
Anyway, the guy that invented Pringles was very upset the fact that every time he got a bag of chips over time, you don't eat them all at once, they get broken, right? Towards the end of the bag of chips, it's all crumbs usually.
Yeah.
So what he decided was like, there's got to be a better way to package potato chips. So that's why he started packaging them in a cylinder. But if you lay chips flat, if you're carrying them somewhere, if they're in your car, just the shaking of it breaks the chips, and you wind up with broken chips again. So what he developed was he's a mathematician. He knew of the curved shape from a conic, and it's called a hyperbolic paraboloid. Now you can kind of get the idea of that this kind of looks like a Pringle if you're looking at it sideways there. It's the hyperbolic paraboloid shape of a Pringle. When they stack them in a can, you're able to fill the entire can, and it's obviously you still get a couple that'll break here and there, but they hold more rigidity because of the strength of the curve. Curves are very strong.
Are they?
Yeah.
You're not Cocoa Puffs?
I'm not Cocoa Puffing you. Seriously. So the guy that invented Pringles was a mathematician that didn't like broken potato chips. So every time I draw an infinity sign, I think of potato chips, and it makes me a little bit hungry.
Yeah, now that I think about it, it's really good.
And now he's rich. Don't know.
I really like that.
Took the money with him to his grave.
I don't know, but I do know he was a mathematician. Maybe that was his neighbor. All right. So what about the other one? What'd you guys get for the other one?
Parallel to like
These guys were parallel?
that's what I got.
So if these guys are parallel lines, how many solutions do they have? None. No solution. So remember, the trick here is with these types of problems. If you wind up with the exact same line, you have infinite solutions. If you wind up with the same slopes, but different intercepts, then you have no solution. Okay? Does that make sense?
Yeah.
All right, let's try some more. Try these two. Remember, what you want to do is get y by itself and find the intersection point.
Why is it always
You should have heard him talking to us, guys.
I did.
Walked out.
Bottom too.
It's quite fun.
That's convenient. You already had the other graph in there.
Is that why it's negative 1?
Is that ridiculous?
Do they have opposite reciprocal slopes?
No.
Or are they perpendicular?
That's why I gotta say that.
Wait.
Second, calculate 5, 1, 2, 3.
Oh, you press it 3 times.
Can you go back to the y equals b? I want to see if I did it.
I have it as 2x plus 5 and negative x plus 2. A lot of times what happens with these things, guys, you just type it in incorrectly. Or if you're dividing out by your the coefficient of y, sometimes students forget to divide out the c value as well. I'm thinking b.
Why did
Yes,
I
ma'am.
do?
Why did it equal the same as the first one?
Dumb block.
Yeah, dumb luck.
Seriously, that's all it is. It just happened to be dumb block. That's all. Yes, ma'am. Negative 2 instead of 2. For what? When you typed it in, or did you not move these?
At the Y intersection. That's the first
All right, let's check the other one.
Second curve, second Y intersection.
On the other one,
One more time.
we have 3y is x plus 3, so you get 1/3 x plus 1. And then I'm seeing I'm also getting a 1/3. So I know I'm going to get a parallel here, aren't I? So I have parallel here. Everybody see how I'm stopping right away because I know it's going to be parallel? Or should I or am I going to have the same line?
Actually, didn't she? Yeah, same,
Oh,
same
I'm going to get the same line when I divide everything out, all
Nice
right.
in your
So this is my hyperbolic paraboloid.
Oh, you're
Pringle
right.
baby.
Can I call it the Pringle?
Pringle.
Oh, so both of them are 1/3 X.
Yeah. But not always is everything clean. Do I? What? Wrong button. Sometimes you get stuff like this.
Oh, my silver.
How about you go to space?
Oh, what is this?
This is a problem that you would not want to do by hand.
This is dirty.
This is a problem you would not want to try and graph by hand because you're going to get, well, first of all, you get some nasty intercepts and a god-awful looking slope. Yes, sir.
Please keep talking here.
I'm asking you something. I know what you're about to say, but that's why I'm asking you something. Use the graphs. We'll do the algebra stuff. So in this case here, come on guys. Once again, you have to be very cautious in how you enter this into your calculator, making sure you are correct in writing out your fractions. So take a minute and try out this one using, remember, alpha y equals allows you to put the fractions in. All right, let's take a look.
Is it still gross? Is it still like two decimal?
Guys, hold on. When you get to this point here, you wind up with 3y is negative 14x plus 16. Divide everything out by 3. There's your value of y. Second one, negative 5y is negative 7x plus 34. Divide by the negative 5. This is where most of you mess up. When you rewrite the problem, you tend to forget to put the negative with it. Y is 7/5 x minus 34 over 5. So, typing them into your calculator. Yes. Yeah. So, in the first equation, alpha y equals negative 14 over 3 x plus alpha y equals 16 over 3.
You have 6.
Thank you. And then the next one we get alpha y equals 7/5 x minus alpha y equals 34 over 5. And then you grab it. Nice.
Where's your other one?
Takes a second for it to show up. Now, it's just a matter of hitting all the buttons. Second, calculate, 5, enter, enter, enter. Negative 2, or excuse me, 2, negative 4. It's math magical.
Can we go back to that one?
Sure.
I'd rather sell it out of the ring.
That's what I have down there.
That's why. Yeah, Paul.
Yeah, he doesn't stack.
This, you're not going to want to solve this system algebraically. It just, I mean, you can. Obviously, it's not that bad. Multiply top by 5 out of like 3. You can eliminate it out. But sometimes it's just as quick to be able to use your calculator. Plus, what's nice about the calculator is that you can always check your solutions. Okay? So what this leads us to be able to do then is that also in this chapter we deal with a lot more word problems. So what we need to be able to do is write our word problems out correctly. So in this case here, you are planning to go to Florida for 7 days. You estimate that it's going to cost $275 a day in Tampa and $400 a day in Orlando. You have budgeted for 7 days $2,300. So now what you have here is a system of equations, and you have to be able to figure out the 2 or more equations that you have to solve to write out. So what you have to be able to look at here is what are the 2 things that are being discussed? Well, one of the things that's being discussed is the amount of days that you're going to be there, and the other that's being discussed is the amount of money you have total. So what are your total number of days? What's the total number of money? So you have 2 equations right away. Something has to equal 7, and something has to equal 2,300. Do you know how many days you're spending in Tampa?
No. X.
How many days in Orlando?
Y.
And now what do you do with the 275 and the 400 for the money part?
275x.
Good. Now, when you have a setup like this, does it matter which one you call X and which one you call Y?
Sometimes.
It does not, but you just have to be very cautious as to how you keep it straight. So if you're going to call Tampa X, that means in the second part, make sure you're multiplying, 275 times X. Otherwise, you can get an invalid statement. So now you have a system of equations. Use your calculator, solves, and it works. Y is negative X plus 7. Y is negative 275 over 400. X plus 2,300 over 400. Once again, as you go that route, All I did there was solve for y, and I'm not worrying about simplifying fractions. Bless you. I'm not worried about doing any of that because the calculator doesn't care. The calculator is just happy that you're pressing buttons. The calculator is happy that you're letting it be part of your lives today. And just a matter of typing in the values. Second, calculate number 5. Enter, enter, enter. Bada bing, bada boom. There's your answer. Okay? Wow. That's what happens when you don't pay attention when you're typing it, so that's not going to work at all.
Oh, what the? Hey.
Don't worry about it.
Oh, it's.
This is why I don't like using the emulator all the time. It takes so long for it to type in.
I thought it was 250.
2300, I think. So let's see.
No.
Did you get 4 and 3?
Yeah. Yes.
Yeah.
You got it all right?
Yeah, we got 4 and 3.
All right.
I figured that's what we need.
All right, try this last one, then I'll give you some problems. Hours and money. So. How many hours are you spending biking?
I don't know.
6 hours, yes.
Why?
And then we do our system. So which one you elect? Negative x plus 5. The other one would be I would write it out so that way you can solve for y real quick. That way you make sure you don't type it in incorrectly. Boy, the graph looks exactly the same as the old one.
That's kind of what I said. Probably,
Did you get 2 and 3?
yeah. I get it.
Hold on, I'm so
It was
down.
practically the same.
This is why I'm saying this is good practice for us to remember how to press buttons on the calculator. It's not a really.
I love this guy.
So tonight, what I have for us tonight is 6 graphs and I think 6 word problems. It starts on page 142. 2 and 3? Yeah. It starts on 142. I'd like you to find the graphing solutions of 26 through 31.
Right, it's down to you, right?
And then the other part is numbers. Oh, I forgot the right number. I have it down over here. Excuse me.
Just work for me, girl.
The other ones are numbers 54 through 58 and 65.
That's me.
I am. There's your homework.